Now the next example for conversion of FA to RE by elimination of state, we'll consider this example. This is little bit complex than the previous one. Okay, so here we'll see how to convert FA into RE. Okay, so here no more refinements are needed in case of transitions. Okay, so directly we'll see the rule. Okay, so here the seventh rule can be applied. Okay, so this is the situation same as the seventh rule. Okay, so in the seventh rule we said that if this is the situation, then this diagram will be converted into this. In this resultant diagram, the new initial state is added. Okay, so we will add here the initial state, okay, or one more state to the A. Okay, so here the resultant diagram will be then 0. Okay, so instead of Q2 we will have Q4 state. Okay, after that we have empty transition, then we have Q2, then 1, then Q3, then 0, then 1. Okay, so this diagram is converted into this diagram according to the seventh rule. Okay, now the next rule will be applied. Okay, now here we can see that here we have the outgoing transition for final state. Okay, so the rule 8 will be applicable here. Means if we have outgoing transition from final state, then this diagram will be converted into this. How this final state will be converted into intermediate state and new final state will be generated for this. Okay, so we will convert this diagram into the new one. Okay, so Q1 remaining transitions will remain same. Okay, just we have to add one extra final state for this state. Remaining transitions will be same as previous, so this will not be final state now. Okay, and Q3 0, and we will add here one more final state. Okay, so that will be named as Q4. Okay, here is empty. Okay, now here no refinements are needed here onwards. Okay, so if we remove, now we will start to remove the states one by one. Okay, so if we remove this state Q4, then resultant finite automata will be Q1 1. So from Q1 to Q2 we'll move by zero dot empty according to the concatenation rule, that is third rule. Okay, okay, so the remaining transitions will be same. Okay, now 0 dot empty means 0 only. Okay, now we'll start to remove the state Q2. Now in this case we will remove Q2. So after removal of Q2, we can have the transition from Q1 to Q3 as 0.1 empty can be omitted, 0.1. Okay, Q3 has 0th cycle. So we'll see what will be the changes occur after removal of this Q2 state. So we will move from Q1 to Q3 directly by concatenating 0 to 1. Okay, after this removal of Q2, this also will get affect. Okay, that is Q3 we have cycle for 1.1. Okay, so we will add cycle of 1.1 here, and here we have empty. Okay, now here the first rule is applicable. So according to the first rule, if we have number of cycles, then that will be converted in this diagram. Okay, so we will number 8, 2, 3, 4, then 5th step. Okay, so Q1 1. Okay, so what will happen here? This is QF. Okay, empty. So here these two will be written as 0 plus 1 1. Okay, now we will remove this state because we want only initial and final state, and no more refinements are needed in case of transitions. Okay, so 6th step will be, we will remove this state Q3. Okay, so Q1, after removal of Q1, what will happen? We have the transition for 1 here, and then we will move from Q1 to QF. So this will be concatenated as 0 1 dot 0 plus 1 1 bracket star dot empty. Okay, so the resultant RE will be, first we have loop for 1, then 0 dot 1, then 0 plus 1 1 bracket star. Okay, so this is our final regular expression for this given finite automata. Okay, so if you have any queries, then please comment on it. If you like my videos, then please do like, share and subscribe to my channel. Thank you very much.